Hey everybody, this is Michael Parent from Michael Parent Consulting Services. In a previous video, we talked about measurement system analysis, and this is kind of a continuation of that topic. In that previous video, we talked about how what we see in reports and the business decisions that we make from the data we collect is not just reflective of what was actually going on in our process or in our business, but it's also a function of the measurement systems we use. And if we have a lot of variation, if we have a lot of error within our measurement system, then we're going to create a lot of bad data without even knowing it. And we won't know where this bad data comes from or how to detect good data from bad data. And consequently, we'll make bad decisions, such as maybe passing things at the end of your production line that it goes onto a customer that should have been caught and sent back for rework or scrapped, right? So we protect the customer by having good measurement systems, but also, maybe in some production facilities, we're making a recipe, right? And we're I've worked in rubber manufacturing, and we're mixing different types of process chemicals and additives. And if we have measurement errors within those production departments, or maybe we're adding too many additives in, we're changing material properties in a way that is not desired, but we're also adding a lot of cost if we're adding too much of the stuff without capturing it. So this is why understanding measurement error and reducing it, at least assessing whether or not you need to reduce it, is important for us. But in this last conversation, we talked about gauge R&R, which is repeatability and reproducibility, which deals with actual measurements of our parts, like weight and height and depth. Well, a lot of times we're not interested in these measurements per se. We're interested in assessments, namely whether or not something is good or bad, right? Pass or fail. So if this is the case, we use a different type of analysis. It's still a measurement system analysis, but we're measuring attributes. We're measuring whether this piece in production is good or bad. And we do a very similar approach to it when we get to the data section. So I have an example here. It's very similar to what we did in the gauge R&R, but rather than looking at the measurements of each of these things, we're looking at just the assessments. So in this case, let's say I am a cheese cracker connoisseur, and I have denoted that these three turtles, the ones with the X's on them, are not good. They do not meet my standards. This one does not have a good enough embossment of the cracker, and these two over here are over embossed. And for that reason, I've deemed them bad, and the remaining 21 cheese crackers good. Okay, now how do I compare that? I want to send this, let's say I'm the master, and I say, I'm the sommelier, I'm the cicerone, I'm the connoisseur who knows what's a good cracker or not. Now I need to look at my inspectors, and I need to see if they agree with my master opinion. And if they do, we would say that we have a good measurement system. If not, we have a bad measurement system because there's some bias in some way that needs to be remedied, and we need to figure out what that is. So the attribute analysis for attribute R&R for measurement system analysis is used for all these reasons. We want to assess the inspection and workmanship standards across my customer requirements. We want to determine if all inspectors are using the same criteria for good and bad. We want to quantify the inspector's abilities. We want to identify how well inspectors are conforming to the known master. In this case, it was my opinion as some dignified cheese cracker chef or consumer. And then we want to discover where our areas are to improve. So again, if we go to the data tab now, what we have before we had this kind of measurement, what was part 1, what was part 2, what was part 3 with actual measurements. In this case, we have the parts over here, call them samples in this data. And let's say we were looking at plastic cups, some red plastic cups. And the master came in and they said, this is the standard. These are um, part 1 is passing, part 2 is passing, part 3 through 5 is failing, etc., etc. That's the standard. That is the known correct answer. Now, how does operator 1 conform to this? And again, we're running separate trials to show conformity between the operators, between operator 1, 2, and 3 and the standard, as well as within the operator. Does operator 1 always fail number 3, or do they pass it sometimes, like operator number 2 did? Failed it once, but passed it the second time. That's going to show us that there's variation in the process that needs to be removed, or at least it's suspect, because it's going to increase the measurement variation and reduce our total confidence in making a good business decision. So that's what we do, is we just run trials with different operators, looking for agreement within the operator and between operators and agreement with the standard. And then our outputs look just a little bit different. We won't bore you with the data up here, but essentially this data populates these charts. And what these charts show us is really the variation between operators and from standards. So you can see here that operators to standards, very, very good. There's almost total agreement with all of these. And then the operators to self, we can see that operator 2 has a lot more variation than everyone else. See how these are much smaller? There's, at worst, they're 80%, and at best, they're in total agreement, 100%. But operator 2, at worst, they're 50%, and at best, they're just shy of 100%. So what we would say here is that our measurement system is great from a standard perspective. If we go back to our litmus test over in sheet number 1, we can probably ask some of these questions. Is the ability of inspectors to accurately repeat inspection decisions is probably not great for operator number 2, but they probably all have the same criteria for determining good and bad against that known standard, because they all performed very, very well with that known standard. And again, if we go here, we can see that in general, everyone was performing fairly consistently. So we would always want to, improve these bottom areas and move them up. So, maybe they're ranging between 70 and 95%. But really, we could start to do that by training operator number 2, because this is the source of the greatest variation in our measurement system. So in sum total, this is another way to assess your measurement system if you're using this attribute pass fail good bad way of inspecting your products, particularly at the end of a production process. So very, very handy, and helps us protect the customer and make good business decisions, and is a great source of improvement without actually having to change too much of the process. We're actually just going to change how we measure the